Now let us learn the new chapter, chapter number 8, transition and inner transition elements. Now in 11th standard, when we learn the chapter periodic table, into that I tell you that there are the 4 different blocks in the modern periodic table, that are the S block, P block, D block and F block. Now S and P block we studied in 11th standard. Now in this 12th standard you have to learn about the D and F block elements. Now the D block include these transition elements. That means transition elements belongs to the D block element. Now what is the main difference between the transition elements and D block elements? The transition elements are those elements in which the D subshell is incompletely filled in their electronic configuration of the atoms. Remember that. Then you say that the D block elements are those elements, madam, in which the last electron, incoming electron, enter into the D orbital. Then what will be the difference between the D block and transition elements? But remember, there is slight difference between the D block elements and transition elements. D block elements are the elements in which the last electron, incoming electron, always goes into the D orbital. But transition elements are those elements in which the D orbital is always incomplete. That means only 1 to 9 electrons are there, because D subshell have the 5 orbitals. So totally 10 electrons can filled into the D subshell. Okay. Then the last elements in the 3D series, 4D series, 5D series and 6D series also the D block element, but it is not the transition element. Transition elements have the electronic configuration n-1d 1 to 9 only and ns 1 or 2 in this way. But the electronic configuration of the D block element is n-1d 1 to 10 and ns 2. Here they give us the general electronic configuration of transition elements as 1 minus D 1 to 10 and ns 1 to. But this is the electronic configuration of D block elements, and the transition elements have the configuration only up to n-1d 1 to 9. That here that is not clearly give the electronic configuration of transition elements and D block elements, but they are the difference. Now remember that. So the transition element belongs to the D block elements, and the transition metal atom have the incomplete D orbital always. Remember that, not complete. It is always incomplete into the transition elements. They exhibit the properties between the S and P block elements, and modern periodic table have 3 to 12 groups, because first and second group of the alkali and alkaline earth metal of the S block. So from 3 to 12 there are the D block elements or transition elements, and from 13 there are the P block elements, 13 to 18. We know that. The general electronic configuration here given that of the transition elements as n-1d 1 to 10 ns 1 to, and the position of these transition elements is they are placed in the periods 4 to 7, that is the horizontal series periods up from 4 to 7, and 7th period is always incomplete, we know that. And the groups from 3 to 12 into the periodic table, that constitutes the 3D, 4D, 5D and 6D series of these transition elements. Now let us first see the electronic configuration of the 3D series or first series of the transition elements. Now see on the blackboard. See on the blackboard the 3D series. Now here what is there in the 3D series? What is there in the 3D series? See there. There are the elements from scandium to zinc. And I give you in the 11th standard the one sentence to remember all these elements. There are very simple. The atomic numbers are from the 21 to 30. That is very simple to remember. But the symbol how we remember that are very important. Now I give you one sentence about that. And that sentence is super class TV crown money patla फेकोनी क्यों झिड़कारला. I already give you this sentence to remember the sequence of the symbol of the 3D series in the 11th standard. And from that we can write the electronic configuration also. Now these are the condensed electronic configuration I show here, because up to argon there are the 18 electrons. Now how many remaining? 3 electrons. The first goes into the 3D1 and 4s2. 3D comes first and then 4s2. Now see here, 4s come first and then 3D come. You know that the energy levels of that. Always the 4s first get completed and then electron enters into the 3D orbital. So the 18 plus 2, 20 and the 21st electron go into the 3D orbital. Remember that. Now up to the, now these are the expected configuration I showed here. Very simple expected configuration. Only increase one electron into the d orbitals. And 4s orbitals have the 2 electrons. And these are 18 because 22 means 18 plus 20, 18 plus 2, 20 plus this 22. 18 plus 2, 20 and this 23, 3 electrons. Very simple. Up to the, that is zinc also. In zinc, d orbital have the 10 electrons in this way. But we expect this configuration. But there is slight difference into the, that is the observed configuration. The observed configuration are different from the expected configuration of only the 2 elements, and that are the chromium and copper. Now what happened here? Now see here, in chromium, that in the expected electronic configuration, as we expect 18 plus 2, 20 and 4 electrons go into the d orbital. But these d subshell have 5 orbitals, and if the 5 orbitals have one electron into that, then that d subshell is that is the half filled will be there, because half filled orbitals or subshells are more stable than the partially filled orbitals. Now here see, if there are only 4 electrons into the d orbital, it is partially filled. But what is the expected configuration? The 1 electron from the 4s enters into the d orbital. Now what happened here? This d orbital is half filled now, because 1 electron in every orbital. And here 4s orbital is also half filled. Though here 4s orbital is completely filled, because s orbital contains only 2 electrons, but this is the partially filled d orbital. Now as compared to partially filled and completely filled orbitals, the 2 half filled orbitals are more stable. Now that is why the observed electronic configuration of that chromium is not in this way, that is the argon 3d4 4s2, but it is argon 3d5 4s1. Remember that. That is the its correct configuration. Now again from manganese to nickel, no problem. There are in the manganese, in the d orbital 5 electrons and 4s orbital contain 2 electrons. But as we go to the copper, see here, in case of copper, we expect that copper have the atomic number 29. So argon plus these 2, 18 plus 2, 20, and 9 electrons goes into the 3d orbital. But here also, if the d orbital contain 1 electron extra into that, then that will be becomes completely filled. So what happened in case of copper again? The 1 electron from the 4s orbital goes into the 3d orbital. Now this 3d orbital have the 10 electron here, that is completely filled, and 4s orbital is half filled. Now as compared to the partially filled 3d here and completely filled 4s, the completely filled 3d and half filled 4s orbital are more stable. That configuration is more stable. So in case of copper, the expected configuration and the observed configuration are different. Now that is the correct electronic configuration, and this is about that the stability of the orbitals. And in case of zinc, there is no problem, as it is there are the 30 atomic number of this. So the argon 3d10 4s2 and the both of the configuration are similar in case of this that is the zinc also. But as we see the definition of transition elements, zinc's atom is not into that of the transition elements. But zinc ion, after giving 1 or 2 electron, zinc ion is the transition ion. Remember that. Now in this way there is the slight difference between the transition elements and d block elements. Now you can study very clearly about the configuration about this 3d series. Now see the electronic configuration again. Since zinc has completely filled n-1 d orbital in the ground state, so 3d10 4s2 is the its electronic configuration. Its common oxidation state is +2 because 2 electron from the 4s can be given out, and it is not regardless as the transition elements, but its ion is the transition ion. On the same, the cadmium and mercury from the 3d and 5d series, if you see the that is the periodic table of the that is 4d and 5d series, into that cadmium and mercury are the last elements. Cadmium and mercury are the last element. So they also have the completely filled 3d orbital, and therefore they are also not the transition elements. Remember that zinc, cadmium, mercury, these are not transition elements because they also have the completely filled. In case of cadmium, 4d orbital is completely filled. In case of mercury, 5d orbital is completely filled. So copper, and again see, in that copper is the elementary state and contains the completely filled d orbital into the observed electronic configuration. It also gives the 2 electron and form the +2 state, and hence copper ion also is the transition ion. Remember here. Again copper in the atomic form is not the transition element because its observed electronic configuration have completely filled d orbital. Now these are the about the general electronic configuration of the 3d series. We will see about the 4d, 5d and 6d series electronic configuration later on.